This video is on sinusoidal models, sometimes also called trig functions or trigonometric functions as well. There are many quantities that vary periodically with time. Such quantities can often be described by sinusoidal models, which are functions of the form y equals a sine bx plus d, or y equals a cos bx plus d. So the amplitude is a, the value in front of the sine or cos, and that is the distance from the middle of the graph either up to the maximum or down to the minimum point. And as you can see on the graph there, it is this bit in black here. Just circled it. The period is a distance for one full cycle of the graph, and we work that out by doing 360 divided by the b value. So in the graph, it's the green part at the top, and obviously if the graph was to start at the maximum point, when it reaches the maximum point again, it's done one full cycle. The principal axis is y equals d, so that is the middle of the graph. So the middle of the graph is that d value. The largest value of y is d plus a, because d is the middle, a is the amplitude. So if we add those together, that will tell us what the maximum value is, but also the minimum value. If we did d minus a, that would tell us where the minimum value of the graph is. The sine and cosine graphs have the same shape, but the only difference is they have a different starting point. So a sine graph starts on the y-axis. So it starts here. The middle of the graph is on the y-axis. It could be moved up or down depending. A cos graph, the y-intercept is at the maximum or the minimum depending how the equation is formed. So for sine, the graph starts in the middle of the graph, and for a cos, it is at the maximum or the minimum. So just a couple of examples. So the first one, a model has the form f of x equals 2 cos 180x plus 1. First of all, find the amplitude, then the period, then the equation of the principal axis. What does the model predict is the value of f of 3, and then what does the model predict the largest value of f of x? So let's start with the amplitude first. So the amplitude is just the a value. So let me just write up here first, y equals a cos bx plus d. You're probably wondering why there's no c. In the general form of this, there is a c in it, but for AISL, we do not look at that c value, which is why it just seems to magically not be there. All right, part A, the amplitude is the a value. So the a value is at start outside in front of the cos, and in our equation, that is 2. So our amplitude equals 2. B, find the period. So we looked at before and we said the period was 360 divided by b, and the b is the value in front of the x, which in this case is 180. So our period is 2. C, find the equation of the principal axis, so that is our d value. It's when y equals d. It's an equation, so we have to write it as y equals. And our d value is positive 1, so it means our equation is just y equals 1. Part D, what does the model predict the value of f3? We sub 3 in for x, so we'll have 2 cos 180 times by 3 plus 1. You literally just put that into your calculator and you'll find that equals negative 1. Now the largest value the model predicts is the maximum, and so we look, remember for this one, we do d plus a. Because d is the middle of the graph, a is how high the graph goes, so we add those two together, which means we'll have 1 plus 2, so our maximum is at 3. Next example. The depth of water in a harbour in metres is modelled using a function of the form h of t equals a sine bt plus d. Where t is the time in hours after midnight, it is believed that the depth varies between 3 metres and 5 metres with a period of 12 hours. Find the depth at 3 p.m. We've been given some information here. Now we need to be working out what our values of a, b, and d are. We can then find what the depth is at 3 o'clock. So with the information we've been given, we know that the depth varies between 3 meters and 5 meters. So that means our minimum is at 3 meters. So 3 would equal d minus a. Okay, because d is the middle of the graph, and then we minus a to find the minimum. We also know our maximum is at 5 meters. So 5 equals d plus a. Nice and simple here. Look, we've got two variables, two equations, solve them simultaneously, and then you'll find that a equals 1 and d equals 4. Now we've worked out our a value and a d value, we just have to do the b. So we're told in the question that it's a period of 12 hours. We know our period equals 360 over b. If our period is 12, put that into your calculator and solve it, and you will find that b equals 30. Now we have our a, b, and d values, so we can make our equation. A is 1, so we need to write it, so it'll be sine of 30t plus 4. Our question has to find the depth at 3 p.m. Now in the question, it also tells us time and hours after midnight. So we need to work how many hours does it take from midnight to get to 3 p.m. And that is 15 hours after midnight, so we can put 15 into our equation, which equals sine of 30 times 15 plus 4, and then you will get an answer of 5 meters. And that is sinusoidal models.